Todd Frazee, and this is the video tutorial on how to CAD model the 7311 Pivot Arm Revision A. Okay, this is the one of the parts of this vise stop, and we're going to start off in Fusion. And the first thing you want to do in Fusion is you're going to want to save it off as the name. So as per the assignment, you're going to sign it off, put in the format of the part number 7311 underscore the word abbreviation REV in caps and A, because that's the version we're doing, underscore, and you're going to put your first initial and last name. So in my case, it would be T. Frazee. Make sure you're saving it somewhere you know where it's going. Okay, and then we're going to start off by drawing the overall shape. So we have a outside perimeter. We have basically a rectangle with a full radius on one end. So we're going to start off that shape. Our origin for all our dimensions is this top right corner. So I'm going to elect to model it just like that in Fusion. I'm starting with a sketch from that view. Okay, so we're going to go to Design, and we're going to make a new sketch. We're going to make that sketch on the front plane. And we're going to use the Line tool. We're going to start to the left of Origin. We're going to go to Origin. We're going to drag down, make our rectangle. We're going to click. And then if we want to make an arc, we click and hold the button down, and it'll turn into an arc. And we'll close that up. Now it assumed tangency for my lower one. The top one it did not. Depends on how careful you are in selecting it. But we want both of these tangents. So if yours do not result in two tangent ends to this arc, make sure that they have these symbols for tangency. Okay, now we can put our dimensions on. If we go back to our drawing, okay, we have it's 1 inch tall, so we're going to take and dimension to 1 inch, and we're going to dimension the length from the end to where our arc ends, the arc center, which according to our drawing is 5.9. Okay, so we should have a fully constrained sketch. If you expand your sketches, it should have the little padlock there. Because we have tangency points here, it forces this radius to be half whatever this dimension is. Okay, so now we're going to select Finish Sketch, and we're going to do an extrusion. Let's look at our extrusion depth. It is 3/4 of an inch, or 750 thousandths. So we're going to put in 0.75, and we have our basic shape. We're going to make the pocket that's in the face of this. So we're going to go sketch. We're going to sketch on the face of our block, and we're going to repeat something similar to what we just did to create the shape we have. So we're going to start with a line. Okay, we're going to start off on the right hand side edge. We're going to draw a straight line as horizontal as we can. Then we're going to hover over the end of that line and hold the button down so we can make an arc. And then we're going to continue with the line until we reach the other end of the part. So we now have the shape of this pocket here, which it's 5 inches to center, and it's a 1/2 inch wide. Okay, so we're going to put our 1/2 inch dimension in first. We're going to come and we're going to go from one end to the center. That's 5. And then we want to center this within our workpiece here. There's a couple of methods we can use for that. What I'm going to do is I'm going to create a line from center to midpoint of the edge on the right. And then if we take this line we just created, we highlight it, right click, turn it into construction, and then we can select the horizontal vertical command and force it to be horizontal, and that should snap our shape into being centered on our material and horizontal. And if we change the size overall of our part, it'll remain centered with that parametric relationship. We're going to hit finish sketch. Now you can use push pull or we can use the extrude command. I'm preferential to the extrude command. And we're going to select the boundary inside that we're going to actually cut. Now it defaults to new boundary. What we're going to do is put in a negative distance of it looks like it's 0.08. Okay, and we're going to switch it from join to cut. Sorry, there it's going to be negative. Okay, negative 0.08, which gives us our pocket. We're going to select OK. Okay, so this feature and all the features that modified are also appear on the opposite side of the part. So we could model that again, but another way to do this would be to mirror this feature here. So we're going to construct a plane at the midplane between two faces, and we're going to select the outside faces of the part. And that'll create a midplane that's halfway between the part, and it doesn't matter what size the part is. If we change it, it'll move with it parametrically. Okay, so now we're going to go to create, and we're going to do a mirror of the feature. So we're going to go switch from bodies to features, and that allows us to pick the extruded cut we did on the first side, and our mirror plane is going to be the plane in the center that we just created. So we're going to hit OK. And now we should have that trough cut in both sides. Now we're going to go and make fillets. Now at the moment we don't need this plane visible, so we're going to make it invisible. And we're going to go through and do our fillets. So if we look at our drawing, we have two fillet sizes. On the inside we have a 2 times 0.25, and it wraps around the inside of this pocket. So we're going to do that one first. We're going to use the fillet command, and we're going to select the loop around the inside of the first pocket and the second pocket. Okay, and that's one fillet size, and we're going to put our fillet size as 0.25. Okay, now we're going to create another selection set. We're going to select these two outer edges, which are a different fillet size. Make sure you're getting the edge and not the surface. And according to our drawing, that fillet size is a radius of 188 thousandths. Now I happen to know that that is 3/16 rounded up. So the real number is 1.875, and so that's what we're going to put in, and that way our tolerance is modeled so that we can use fractional radius gauges. So it's going to be 0.1875. And we have our fillets now on the exterior of the part. We should be able to hit OK. And we now have a good portion of this part modeled. Okay, so the overall shape, we should have pockets with fillets on both sides. And then now what do we have left? We have this hole feature here, and this thing's a mouthful. So it's a counterbore with a tight tolerance through hole. And it has a chamfer call out on both ends. We're going to make as much as we can with a counterbore tool. But we need to make sure we're observing these figures here. Okay, so let's go. We're going to create a hole. It's a counterbore hole. The tap type's going to be simple. And we don't care about drill point or not. It's going to go all the way through. So we're going to change this to through all. And then we should be able to snap to have that concentric. Now it defaulted to this huge screw size that we're not doing. So let's modify our numbers. So our hole diameter, according to our drawing, is a tight tolerance shoulder bolt size. So it's a 252 to 250. So we're going to draw that halfway in between that tolerance at 251. 0.251. Okay, that's the through hole. And then we're going to look at our next box is going to be the depth of our counterbore. So let's go back and look at our drawing. And the depth of our counterbore is 188. Okay. .188. Okay. Now we could do an 875 because that's probably what it is. So we'll do that. 1875. Counterbore diameter is 0.406. Alright. So that gives us our major features here. We're going to select OK. And there's our counterbore. Now what we're missing is the edge breaks. Chamfers that are on these holes here. Now there's a couple, or countersinks. There's a couple schools of thought. You could leave them unmodeled and machine them. But what I like you to do is get practice using the software, machine the modeled in fillets, because if you're working somewhere where you're receiving a model from someone else, you may have no choice. So we're going to run through the calculation on here. So let's go look at the first one. So if our basic feature size on the near side is the countersink. So we have a 401 hole with a 460 chamfer on it, or countersink on it. So if we take 0.46 and subtract 0.406, that gives us a 50 to 60 thou countersink. Half of that's going to come off one side and half the other. So if we divide that in half, that gives us a 27 thousandths chamfer size. Now we have a pretty good tolerance on this, and so I'm going to go ahead and round this up to a 30 thousandths chamfer. Okay. So we'll go back to Fusion. We're going to go to the modify command. We're going to use the chamfer command. And we're going to pick on the top of our countersink and make that a 30 thou chamfer. Now, let's go back to our drawing. Let's calculate the next one. Okay, the next one is on the far side. So our basic hole size is 251, right? So if we take the countersink of 0.31 minus 0.251, we have a 59 thousandths. Okay, so it's really probably closer to 60. Divide that by 2. It's 29,000. So the countersink size on the other side is going to be about the same. So we can go back to Fusion and we just go ahead and select a new set. And pick the edge, and we'll set that at 30. Now you could have done this as one selection set, but because I had hit enter, it accepted that as a selection set. Okay, now down here we probably should have a little chamfer too, and that's going to be covered by our deburr all sharp edges with an R10 max. So we can go ahead and go in there, and we're going to make a chamfer, and we're going to pick this last hole here, and we're going to put 0.01. Okay, now the end of the part, we could put a 10th out edge break on this. It's going to be difficult to machine that from any orientation but the end, and we're not going to stand this up on end just to do an edge break. So what I'm going to challenge you with is this is going to be some of your handwork to see if you can use a file, maybe some sandpaper, and put a 10th out edge break along that edge by hand. And it needs to look clean. Alright, that's it for modeling this part. Thanks a lot, and we'll catch you on the next one.